Okay, let's continue with sections 6.2, 6.3. Okay, example 8. Solve the following equations in radians. Okay, so we've got cotangent x minus radical 3 equals cosecant x. So what I might do here is I might say, okay, well, move the cosecant over to the other side. I might actually swap these two in this case. I know that in the previous example we set them equal to 0, but we actually have two different trig functions here, and I want to see how I can relate them to each other. So cotangent x, the cosecant x becomes minus cosecant x when I put it on the other side, and the radical 3 becomes positive. So now what I can do is I can look at this and I say, well, what is cotangent x? Well, cotangent x is cosine x over sine x. What's cosecant x? It's 1 over sine x, and that equals radical 3. Okay. So this becomes cosine x minus 1, cosine x minus 1 all over sine x is equal to radical 3. Okay. Okay, so if I were to factor out a negative on the top of the fraction here, let's factor out a negative from the cosine x and the negative 1, I would end up with negative cosine x plus 1 all over sine x. And there's a reason I'm doing that. Because this guy here, 1 minus cosine x over sine x, okay, that is a trig identity. And that is our half angle identity for tangent. Okay, so this is tangent of x over 2, okay, equals radical 3. Okay. Okay, so I'm going to divide by a negative and move the negative to the other side. So this is tangent of x over 2 is equal to negative radical 3. Okay, so what is tangent? Well, tangent is y over x, right? So this is going to be negative radical 3 over 1, basically. Okay, but using the unit circle and those special angles that we know in the unit circle, this could be either negative radical 3 over 2 over 1/2, or it could be radical 3 over 2 over negative 1/2. Okay, so those are going to be located, okay, at those tangent values are going to be located at negative. So let's look at the unit circle real quick. So this is going to be a negative y and a positive x. Negative y, positive x, that's fourth quadrant. And the y is going to be radical 3 over 2. And the x is going to be okay. And the x is 1/2. And the y is radical 3 over 2 negative. Okay, so that's either there or it's the same thing, but in the second quadrant. Okay. And this is going to be at negative 1/2 and positive radical 3 over 2. Okay. So the tangent of some angle, which we call x over 2, is going to be equal to negative radical 3 if it is this angle here or this angle here. Okay, so the reference angle is pi over 3. Okay, that's the reference angle. Okay, so the reference angle is pi over 3. Okay, now what is it going to be in the second quadrant? Well, in the second quadrant, it's 2 pi over 3. So one of our answers is going to be 2 pi over 3. Okay, And then another one of our answers is going to be, what's this one? That would be 5 pi over 3, right? In the fourth quadrant. So plus, we'll say plus 2 pi n, and then 5 pi over 3 plus 2 pi n. However, okay, notice that these guys are pi units apart. Okay, so those are pi units apart. So this really is, we would say that x over 2 is equal to 2 pi over 3 plus pi n. Okay, now that's just pi x over 2. What we need to find is we need to find out, well, okay, if that's x over 2, then what is x? So let's multiply both sides by 2. And we're going to distribute through the 2 here. And that's going to tell me that x is equal to 4 pi over 3 plus 2 pi n. Okay. And so that's my answer. Okay. What about the B here? Cosine 2x equals sine x. What I want to do is I want to change the cosine 2x and try to make it into this whole thing to be sines, or this whole thing to be cosines. So cosine 2x, I can use a double angle formula here. And I could say this is, well, this is cosine squared x minus sine squared x is equal to sine x. But I also know that cosine squared x is 1 minus sine squared x. So this becomes 1 minus 2 sine squared x is equal to sine x. If I were to toss everything to one side, I would get 0 is equal to 2 sine squared x plus sine x minus 1. Okay, is equal to 0. Let's let u be equal to sine x. Then we get 2u squared plus u minus 1 equals 0. Now, does that factor? I believe it does. We get 2u minus 1 times u plus 1 is equal to 0. So the outside becomes 2, the inside becomes 1, and we get, when we add that together, we get plus 1u. Okay, plus u. Okay, so that works. So now we're going to say, well, this is going to be 2u minus 1 is equal to 0, or u plus 1 is equal to 0. Okay, good. Okay, so 2u, let's add 1 to both sides there. So this is 2u is equal to 1, divide by 2, so u is equal to 1/2, or subtract 1, u is equal to -1. Okay, so but what was u? U was sine x. So sine x is equal to 1/2. Okay. Or sine x is equal to -1. Okay. Well, where does that happen? Well, sine x equals 1/2. Where's the y value equal to 1/2? Well, that occurs 2 places. Okay, on the unit circle, the y value is a positive 1/2 at either pi over 6 or 5 pi over 6. Oh, okay. Where does the sine value equal -1? Well, it's way down here. That's 3 pi over 2. Okay, so we know that there's 3 places, okay, that this is going to have a solution. It's going to be pi over 6 plus 2 pi n, 5 pi over 6 plus 2 pi n, and 3 pi over 2 plus 2 pi n. So 3 3 different spots on the unit circle will give me a solution. And then all of the rotations around that taken into account for the 2 pi n. Okay, solve the following equations in radians. Okay, so let's just solve directly. This one's linear, so let's just solve that directly for cosine. So 2 cosine, let's add radical 2 to both sides. Okay, so 2 cosine x over 2 equals radical 2. Divide by 2, cosine x over 2 equals radical 2 over 2. Okay, so where's the cosine equal to radical 2 over 2? Okay, again, going to the unit circle, the cosine is the x value. So this is going to occur at pi over 4 or 7 pi over 4. That's 2 pi minus pi over 4. Okay, so those are the 2 places where it's gonna be equal to. So we know x over 2 is equal to either pi over 4 plus 2 pi n or 7 pi over 4 plus 2 pi n. Now, multiply everything through by 2, and we get pi over 2 plus 4 pi n. Okay, that's interesting. Pi over 2 plus 4 pi n, okay, is equal to x, or 7 pi over 2, okay, plus 4 pi n. Okay, so 7 pi over 2 will also work. And I just want to check to make sure that this is not the same thing. 7 pi over 2, what's 2 pi? 2 pi is 4 pi over 2. If I were to subtract off of 4 pi over 2, I would get 3 pi over 2 plus 4 pi n. And I could rewrite it like that as well. I could say, hey, you know what? This is really going to be pi over 2 plus 4 pi n, okay, or 3 pi over 2 plus 4 pi n. Because at 7 pi over 2, that's an angle, but it's one around the circle already. So the angle that the coterminal angle for 7 pi over 2 is 3 pi over 2. So we can write it as its angle in the within one rotation of 2 pi. Okay, B, cotangent 2x minus cosecant 2x. Okay, so we've got a couple of interesting things going on here. Okay, this equals 1, right? Cotangent 2x minus cosecant 2x. Okay, cotangent minus cosecant. Cotangent minus cosecant. Oh, well, I know what that is. The cotangent minus cosecant, wasn't that negative tangent? That's what we got up here, right? That was when we did the cotangent minus cosecant. We ended up showing that that was negative tangent over x over 2. Oh, okay. Well, we don't have to do the whole thing again. We say this is negative tangent of x, but in this case, our x is 2x. So this is 2x over 2 equals 1. That's nice. Okay, so using an identity that we found from example 8, part A, okay, we can just jump right into that. So this is negative tangent of x is equal to 1. So tangent of x is equal to negative 1. Oh, okay. So where are tangents equal to negative 1? We want this to be in radians. Well, they're equal to negative 1 in the 4th quadrant or the 1st quadrant or the 2nd quadrant, negative 1. And we have pi over 4 is our reference angle. Okay, so this is going to be at 3 pi over 4 or 7 pi over 4. We know this is going to be, and notice that they're pi units apart. And so since they are pi units apart, I can just, instead of adding 2 pi to keep going around this thing, I can just say, well, every pi units, I'm back to an answer. So there's really only one solution here, and that's 3 pi over 4 plus pi n. Okay, that's what x is equal to. Okay, and that's it for 6.2, 6.3. I will see you in the next video.